Okay, so the flashcard you should have, on the front of the flashcard it would say F relative max. Try to make my flashcards as little, kind of as brief as possible because it makes the memory more permanent. So then on the other side it's going to say, oh, that's F going increase to decrease, or F prime changing positive to negative. That's what a relative max on F is. Questions? Y'all catch up your notes. Well, this should say F prime, sorry. The key thing here, though, is to notice that this note here about F prime is not talking about a relative max on F prime. It's simply giving a way to find the relative max on F by observing F prime. Okay, it's got a chart, please.
So for relative minimum, it just be the opposite?
Mm-hmm. So me, I don't have a relative min card in my deck. Just because, like what Maggie said, I'm like, no, I don't need that. I can remember that it's the opposite. But either way, it's still perfect. And also the word local min means the same thing, or local max. The word absolute max does not mean the same thing, nor does the word max alone mean the same thing. If you read a problem that says find the max, that doesn't mean relative max. So, another question. Cool. Let's make sure our sound's working here. So when you see this, your brain should be saying, hey, to figure out when F prime changes sign, the words should be guiding you. You see that word sine, and it should be reminding you of sine chart. So I now have concluded, before I do really anything, like I didn't write any of this down, this is just in my memory, that I need a sine chart of F prime. Questions? Cool. So I got to find F prime first, so I have to use the product rule. So there's F. So small class day, I'll pay a full ticket for one person to raise their hand and start talking, and then I'll stop you at the point where I feel like you've said enough. Anybody want a full ticket to go, right?
Like of what to do?
Yeah, just tell me exactly what to write.
So use the product rule, or use the exponential rule first? Or power rule, I mean?
No, you have to start with the product,
Okay.
because I've got one factor multiplied by a second factor.
So we do the power rule after.
The power rule will show up as I'm using the product. Yeah.
Okay. So you would do x minus 3 squared. And then you do g x minus 2 dx.
Perfect. Let's pause there for a second. So again, we're trying to get kind of a nice balance between how much we write and how much we do in our head. So can you tell me the derivative of x minus 2? Perfect. So good enough to just write, it maybe doesn't hurt to write times 1 so I remember that I did that. Perfect for Maggie. Anybody else want to join the great ticket hybrid schedule giveaway? Say please.
Plus x minus 2 and then times by 2 x minus 2.
Is that louder, say?
And then 2 and then proceed x minus 3.
The exponent here would have been 1, and then Sadie would be thinking that I've got to find d of x minus 3, but similar to what Maggie did, d of x minus 3 is just going to be 1 anyway, so doing that in your head again is a good choice. Cool, there's my derivative. Question. So I need a sine chart of f prime, but sine charts are easier the more factored I am. So if I'm making a sine chart of f prime, I prefer to have f prime as factored as possible. So anyone want to earn a ticket, raise your hand and tell me how to factor f prime. Let's go, Madison.
Did you pull out x minus 3?
Just tell me exactly what's right, Madison.
So x minus 3, and then parentheses, x minus 3, parentheses, plus 2, wait, plus 2x minus 4.
Oh, I got you. I'm going to write like this so you can see. So that was the factoring. You wouldn't need me to talk more about that. If you don't see it, make sure you ask. And then what Madison did is she said, well, this factor is a little complicated. If I can simplify that factor, it will help. So she did. She noticed that these two parentheses serve no purpose. So she could drop those. Then she distributed. And cleaning it all up, you get this. Question. Took it for Madison, sorry. I can't remember if you have a preference.
Either one.
Okay. I think it's having trouble. Get rid of that. Okay. That one. What's next? Somebody else? Please, Caitlin.
So you would create next, now you have like two simplified factors. You can now use the separate assign chart.
Perfect. So draw my number line. I actually think it's critical to make sure you're labeling the number line properly. So Caitlin, what label goes here and what label goes here?
So the top would be the like your export and your line.
Perfect. And I'm charting f prime, so that's what I'm going to put here. Keep going, Caitlin.
And then what we do is we try to solve. So you want to find when f prime is either 0 or undefined.
Let me set back to the video. So we're looking to find the x values where f prime has a value, meaning y coordinate of 0 or undefined. So at what x's here, Caitlin, will f prime be 0 or undefined?
At x equals 3.
Make sure my chart's kind of spread out to avoid errors. Keep going.
X equals 3, y equals 0, and then at x equals
Tell me what you're thinking. I have an idea that will help. Like, what's going through your brain?
oh, I'm trying to figure out for the the other factor, 3x minus 7, trying to do it in my head when x equals what would be that 0.
Perfect. Pause right now. That's exactly what I was hoping you would say. So the thinking there is perfect. Caitlin's saying, okay, the whole reason we factored was because when I have a factor times a factor, I now can focus on each factor individually instead of trying to focus on like a big, huge thing like this. It breaks it down because I figure out that if I put a 3 here and I put a 3 here, this factor's value doesn't matter because this factor will be 0. 0 times whatever is 0, so that works. I can do it the other way around now. If I can figure out what to put here, it won't matter what I put here. Because if this is 0, 0 times whatever will be 0. They want to talk more about that. Huge idea. But the next step is where a lot of people get stuck. They'll do exactly what Caitlin's doing. They'll be thinking, okay, 3x minus 7, 3x minus 7. You know, what makes that 0? So don't do it in your head. Again, it's that balance of getting enough on paper, enough in your head. Just write it down. I need this. It's that idea of learning to use the equal sign perfectly. I need that to be 0. So Caitlin, let's see if this helped or not. Once I write that down, can you think of how to figure out what x will make that true?
Yeah. So you would add 7 to both sides and then flip it.
Perfect. No, the little trick did exactly what I was hoping. When you are doing it in your head, you're struggling. You can't quite see it. As soon as you write it down, you're done. So Caitlin, does 7/3 belong on the right or left of 3?
On the right.
Be careful. 6/3 would be exactly 2. So 7/3 is 2 1/3.
So it's on the left.
Yeah, it goes on the left. So I want to make sure I leave some space. Anyone need to talk about any of that? Someone else who'd like to take that? What do I do now? Evan.
Don't you just plug in values, figure out when it's positive?
Yeah, it's the beauty of a sign chart. Once I get the values of f prime, which results are the x coordinates, which will cause f prime to equal 0, the next step is very, very simple. I can pick any x value. It really doesn't matter. And I just try it. So pick an x.
4.
So over here. And again, we are making a sign chart. So we don't want to waste time coming up with numbers. We just want signs. So if I plug in x equal 4 here and here, this will be positive or negative?
Positive.
This one?
Positive.
Perfect. You need me to keep going there? Keep going, Evan. Pick another number.
1.
So does 1 belong here or here?
Left of the 7/3.
There we go. So we plug in a 1 here and here. This will be,
Negative.
this will be,
Negative.
and it's positive. And then one more test value.
2.5.
Sounds good. 2.5 is good. So this is 2 1/3. So I put 2.5 here,
Negative.
2.5 here.
Positive.
Questions? Do we want to talk about it? So let's vote. I'll pay you points, not tickets. Show me your vote. A, B, C, D, or E. What's the answer?
So, in the first quadrant, what do you know about Y and X? Well, positive in the first quadrant, which means our tangent positive.
Hold on, make sure I was thinking. Oh, sorry, vote. A, B, C. Oh, you're working on something else, so you keep working on it. Sorry. If you're doing this, give yourself 4 down. Talk to me.
It's going to be D, 7/3.
Yep, 4 points for Dallin as well.
So
Question, please.
if it was relative minimum, it would be 3.
Yep. Perfect. Oh, and here's one that you might run into. Like you will. This happens. I can never say you will because you never know what questions they'll give you each year on the UP test. But one you need to be prepared for is if they said at what values of x does the function have relative extrema, then both answers. Because the word relative extrema means relative minimum or relative maximum. So you have both. Does that answer your question, Evan?
Yeah.
Okay. Do we have anything else here before I stop the video? So I'm going to help Ariana now. She still has a question. And Maggie.